All right, welcome back, everybody. Day 2, geometry. Hopefully, you guys have all been able to get into OdysseyWare and get some things done. Really need for you to, if you have not, make sure that you get something completed over the weekend. I'm available tomorrow. If you have questions, I have one appointment with a student in the morning. But other than that, I should be available. If you have to text me, that's fine. It's the best way to reach me anyhow. So anybody got questions about anything so far? All right. Hang on just a second. Now with the distance formula, does anybody remember or know what the Pythagorean theory is? Well, I'm going to write it on the whiteboard here and see if this rings a bell. That look familiar? A squared plus B squared equals C squared. This is the theory that Pythagoras came up with 3,000 years ago that can always help you figure out distances on right triangles. Now, for us, since we're talking about the distance formula, we're going to be talking about right triangles, but most of the time we're going to be talking about the distances for the side that is on the angle. That is C in the Pythagorean theory. A is usually the short leg. B is the second leg of the triangle. C is always the hypotenuse. Does everybody know that word, hypotenuse? Hypotenuse is always C. Hypotenuse is always the side that is opposite the right angle. Okay? So when we look at the distance formula, get back to my, if we look at the distance formula, it is a variation of the Pythagorean theory. Let me just go to OdysseyWare, it's got it in there. Which basically means it's solved for C. Now the lettering's different, but you'll notice that it involves the X and Y coordinates. Now, some of you that I've seen plotting points on your graphs in OdysseyWare are not plotting the points correctly. So it's going to be difficult to use the values of the points, the ordered pair, to work the distance formula if you don't understand where these points are going on the graph. Remember, the X and the Y go together. First you move the X and then you move the Y and then you place the point on the graph. So let's take a look at what the OdysseyWare is saying about the distance formula to begin with.
In this figure, triangle ABC is a right triangle. The length of segment AC is easily counted as 4 units. The length of segment BC is counted as 3 units.
Now this would be the short leg. This would be the second leg. The side AB is the hypotenuse because this is the right angle. Now, when we're talking about the distance formula, we're going to be looking at the distance between A and B, because these we can count. We can just count the boxes, 1, 2, 3, to go from C to B. That's what the actress here is doing. 1, 2, 3, 4 from C to A. What is the ordered pair for point A? What is the value for that point right there? What's the XY coordinate? 1, 3, because we went over 1, up 3. We didn't put a point here and a point there. It is 1 point. Over 1 to the right, up 3 immediately. 1, 3. Now what's the ordered pair for B? 4, -1. Good job, Nathan. We went 4 to the right and down 1. 1, 2, 3, 4. Pause for a second. Immediately go down 1. So 4 is your X movement, 4 positive. Down 1 for your Y movement is -1. So each of these points has an XY value, and that's what we use in the distance formula.
The length of segment AB cannot be counted. Therefore, you will need to use a new method. Since triangle ABC is a right triangle, you can use the Pythagorean theorem to calculate the length of segment AB. For this example, the length of segment AB is 5 units. To compute any non-vertical, non-horizontal length, you could draw a right triangle and use the Pythagorean theorem.
Here is the distance formula. What it's doing is taking a comparison of the X values, subtracting one from the other. If you think back to how you found slope, you were doing something kind of similar to this in algebra, because the slope compared to the change in Y to the change in X. Well, because we're talking about triangles now and 2 points within that triangle, it's a comparison that is done in a slightly different way. We're going to subtract one X value from the other and square it and add it to the Y values that we can subtract in the same way and square that. This symbol here at the end, once you do all these calculations, then you have to apply the square root. Now, if you're not sure how to find the square root on your calculator or on your phone, what you're going to have to do is turn your calculator to the side, because when the calculator, and you won't be able to see this because of the way the light is emitted, but the normal calculator in vertical form is just adding, subtracting, multiplying, and dividing. When you turn it sideways, you get a scientific calculator. And on mine, it might be different if you have an Apple phone. I have an Android. On mine, the square root symbol is this little thing that looks like a check mark. Calculators all work differently. You have to play with it for a while. Sometimes you have to put the number in first and then hit the check mark. Sometimes you hit the check mark first and then put the number in. So for instance, the square root, if you remember what the square root is, that's why we have to use the calculator, because there's only perfect squares come out even. None of these are going to come out even. They're all going to come out as decimals. Very, very rarely are they going to come out even, I should say. They might, but most of the time they won't. Because if you remember from algebra, the list of perfect squares, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, etc. When you square root any of those, you get a nice even number. The square root of 25 is 5. The square root of 49 is 7, for instance. But with these, because you're doing these comparisons, these subtractions, probably won't come out even most of the time.
In order to accomplish this, you would have to square the difference of X values and add this to the square of the difference of the Y values, and then take the square root of that. This is more commonly known as the distance formula. If point A is located at 2, 3, and point B is located at 7, 15.
Now here's a perfect example what I was referring to with the plotting of the points. Now we could connect these dots here. If we wanted to make a right triangle, we could use the Pythagorean theory, but that requires some more work. So we can get to the answer directly by using the values from the points. The X value comes first, the Y value is second. It doesn't matter which one you say is the first one or which one is the second one. And when you talk about A here and B, that's totally up to you. You could have reversed it. But the little number ones here with X and Y, that just means that's from the first point. X2, Y2, that's from the second point. So subtracting the X values here, 7 minus 2, square that, subtract the Y values in the same order. So if you started with the 7 for the X values, you have to start with the 15 for the Y values. 15 minus 3, that's 12, you square that. This one does come out even. Then you add those together, you get 169, square root of 169 is 13.
Find the length of segment AB. Start by assigning the coordinates for point A as x sub 1, y sub 1, and point B as x sub 2, y sub 2. Using the distance formula, plug in the values of x and y into the correct locations. 2 and 7 will go into the x sub 1 and x sub 2 positions, with 3 and 15 substituting into the y sub 1 and y sub 2 positions. After some quick calculations, you find that the length of segment AB is 13 units.
And they made those come out even just for those examples, which was nice of them to do that. So if you look at this first set of examples here, if we're looking at the distance between 2 points that have the same y coordinates, you can use the absolute value. Well, that's nice. How do we know that they have the same y coordinates? Well, here's the y-axis, right? Look at the second number in each one of these points, in each of these ordered pairs. What is it? Right. Both of these points are on the same y line, the same value for y. So it should be obvious that you can go from 6 to 2 and that distance is going to be 4 because it's a straight line. It's not on an angle. Those are easy calculations. And the fact that they call that absolute value, to me, is overly complicating it, because all you got to do is count the squares in between 6 and 2. 1, 2, 3, 4. Or 6 minus 2. That is the distance. Both of these points are on the same line, the same level of y. Same thing here. These are on the same level. If you looked at x, at 2 points on the same x number, you can do exactly the same thing. The time that we need to use the distance formula is when things are on an angle. So here's examples on an x value. First number is 2 for both of these points. The distance is 3. 1, 2, 3. Here our x value is -1. The distance is 7. 1, 2, 3, 4, 5, 6, 7. From 2 minus 5 gives you a total of 7 squares. Vertical or horizontal, all you do is count.
So would it be like a -7, or does that matter?
It's just a distance of 7 units.
Okay, so that doesn't matter.
No. I don't know if you guys could hear that or not, but Nathan asked if it mattered whether it was positive or negative. It depends on how you're viewing it, but as a raw distance is just 7 squares. If you're talking about going down from 2 to 5, then you're going down 7. So that would be -7. But if you start at 5 and go up to 2, then it's +7.
Okay.
It's still 7. And it just depends on how you're looking at it. And when they're talking about absolute value, That's what these little straight up and down brackets mean here around the 7. The absolute value of -7 and 7 is 7. Absolute value means what is the positive value of the number, regardless of whether it's shown as positive or negative. Absolute value is always positive. So where we're going to have to use this is when we have these triangles here and we're trying to go find the distance between these points that are on a diagonal. If we have this distance here, but we're trying to find a distance between these 2 points, 3, 8 and 5, 3. Part of the reason that we have to use the distance formula is because diagonal lines, you can't just count the squares. So my 2 points, 3, 8, here's what I'm talking about with plotting points. There's 5, 6, 7, 8, 1, 2, 3, 4, 5 this way, 6, 7, 8. The first point is 3, 8. So I'm going to start at 0 and go to the right 3, up 8. This is 1 point. It's not 2 points. 3, 8. The second point is 5, 3. So I'm going to go right 5 and up 3. So these points are on a diagonal. We can't just count the squares when a line is cutting across the diagonal like that, which is the exact reason that we have to use the distance formula. Now, before, when I said I could make a triangle, I could do something like this, and then I could use the Pythagorean theory, because now I have a couple more points, and this is a horizontal line. It's going from 3 up to 5, so that's 2 on the short leg, 2 squared. Now here I'm going from 3 up to 8, that's 5. And the part that I don't know is the hypotenuse. This is the right angle. Here's the hypotenuse. So 2 squared plus 5 squared, 4 plus 25, 29 equals c squared. And square root of 29. Square root of 25 is 5. Square root of 36 is 6. So it's going to be somewhere in between. .38. Because now I square root both sides. Squares and square roots are opposites. 5.38. And if I've done that right, it should match with what they're showing in using the distance formula. Anybody have questions about how I did that?
So, even though they didn't have that triangle, you could still do that and use that Pythagorean
You can
theorem?
always use the Pythagorean theory. If you can create a right triangle, even if it's just for the purposes of doing the exercise, it's legitimate. You can still use it. That's why I tried to put it on here as dash lines.
Yeah, I see that.
Yeah.
Pretty good at drawing online.
It's not easy because I don't have a mouse. I'm trying to go straight off the touchpad.
Oh, I thought you had a mouse.
No, I don't use a mouse. I don't like a mouse. Well, look at that. They got the square root of 29 also.
Looks like they leave it at that, don't they?
Yeah, primarily because it's a funky number, because on my calculator, it fills up the whole screen with numbers. 5.385164807, blah, 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 blah. Nobody cares about that many digits in a square root number.
Right.
And they're always going to be imprecise like that unless it's a perfect square.
So they'll leave it that, and that'd be the answer.
You could leave it like that, and I don't know if they're going to show it that way or not in the quizzes, but if it shows up as, if all your answer choices are the square root of something, then yeah. The next one they show after that is an example like before, does come out even. So here's a question. Find the distance between these points. I'm going to pause the video here. And good job on that problem. And sorry for my sloppy writing here, but you can tell no matter which way I did the calculations, I still got 5 as my answer.
It doesn't matter what order they're in, like on the x's. Why do they put x2 first and then minus x1?
I don't know.
Okay.
Probably just so that they can have a pattern. But it really doesn't matter, as you can see. Questions about that so far and how to use those ordered pair numbers to do the calculations? And you can see there's going to be a lot of problems in here where you're going to have to do that. Let's try number 5. We'll do the same thing here. All of these answer choices are still in square root form, so that one might be interesting. I'll do the same thing here, and I'll pause the video, give you guys some time to work on it. Okay, if you got square root of 61 for this one, you did it correctly, because you're going to take 5 minus 0, that's 5, square that, that gives you 25. 12 minus 6 gives you 6, square that, gives you 36. Add 36 and 25 together, you get 61. All of that has to be square rooted. So I know where the 11 comes from, but remember when you do those calculations, you got to be sure you're adding them together before you apply the square root. That's where the square root of 61 comes from, and that's not going to come out even either, because the next closest perfect square is 64, 8 times 8. So distance formula, you'll see that's just more of the same kind of questions, same kind of problems in terms of calculating. Now, if you see these where one of the points is a square root number, that will take care of itself also when you square it, because the square root is undone. It's the opposite of a square. Just like multiplication and division are opposites, squares and square roots are opposites. So one undoes the other. After you square it, yes. If you square the square root of 7, you have 7. Yes. If you think about it, the square root of 7 times the square root of 7,
Yeah.
it's going to have to give you 7.
Right, because they just cancel it.
Right.
Right.
Yeah, the square cancels the square root symbol. Another way to think about it. When you get down here towards the end, question number 16, for instance, says, given below are the coordinates of the vertices of a triangle. Remember, the vertices are those corners. It's where the angles come together. Find the lengths of the sides of the triangle, then click to identify the triangle as scalene, isosceles, or equilateral. Now, this is a more complicated problem. And you're going to have to remember those definitions. Scalene, anybody remember what that one is? A scalene triangle has no two sides the same. All three sides are going to be different lengths. So what about an isosceles triangle?
One's longer than the other, like it'd be a right angle.
Not necessarily right angle. You can have an isosceles right triangle. What's that?
Is it that two sides are the same length, but the third one's different?
There you go. That's it. That's isosceles. You have two sides that are the same length, and their opposite angles from those sides are also going to be the same measure. Equilateral is the easy one. All the same, right? So a problem like this, you're going to have to do this calculation 3 times. You're going to have to do A and B. I'm going to show you what I'm talking about here. You got 3 different calculations you're going to have to do, all with the distance formula to figure out this kind of a problem. And I just love these kind of problems. And you guys all know I'm crazy, but that's all right. So I have no idea what this triangle looks like. I'm just going to make one up here. A is on this end. Here's, I'm going to call this B. C is here. And I guess if I graphed it, I could figure that out, but I'm not going to mess with the graph right now. This is 3, 5. B is 6, 9. C is 2, 6. So here, you got to have to do these distances for A to C. Going to have to do these calculations for A to B. And the last one, B to C. So you're going to be doing that same distance formula calculation 3 different times. And because you won't be able to answer the real question until you know what those distances are. And the real question is it a scalene triangle? Okay, if all the distances are different, it's scalene. If you find that you've got 2 sides that are the same length, then it's going to be isosceles. If you find that they're all 3 the same length, then it's obviously equilateral. So it's the same kind of work. It's the same sort of a problem. You just have to do it more of it, if you will, and then do the comparison against the definitions. Hopefully that makes sense. So you got like 4 or 5 examples there. Then they're even going to throw in one here at the end about a rectangle. Find the length of the longest side of the rectangle whose vertices are given. Well, that just means the 4 corners. Rectangle is 4 corners. And see, this is one that I would probably do a graph on first before I even tried to solve it. Because again, geometry being a visual thing with shapes, if you can see what they're talking about here, sometimes it's going to be easier to solve it just by looking at the graph or determining the graph. Now, what I'm thinking here is that this rectangle is probably not perfectly horizontal or perfectly vertical, which is why they're going to ask you to figure out the longest side. But putting it on a graph can help with that. I'll show you what I mean there. I got to write these points down first before I switch screens. Okay, so when I go back to my whiteboard, all these are positive. I'm not going to worry about any of the negative numbers here because I don't have any. 2 comma 1, 2 over 1 up is right there. That is A. B is 5 over 4 up. B. C is 0 over 3 up. 1, 2, 3 right there. C is, or D is 3 over and 6 up. Just like I thought. It's a rectangle, but it's not laying flat, or it's not horizontal, it's not perfectly vertical. So the reason that it's important to do a drawing like this is because you can just look at this visually and tell that this side or this side, those are going to be the longest sides. So you don't have to do 4 calculations here to figure that out. Since it's a rectangle, you know these 2 sides are equal and those 2 sides are equal. So you could do one of these and one of these to make sure you got the right one as the longest one. So help yourself out here and do drawings on these whenever you get the chance. And I'm probably going to ask you that too. Did you do a drawing? So any questions about the distance formula? The next section here, the next formula is actually easier, in my opinion. The midpoint formula. Midpoint formula, as you can imagine, is to find that spot on a line that is exactly in the middle of 2 endpoints. We have a line segment, we have a side of a triangle or a side of a shape of some sort, and we're looking for that point that is exactly in the middle.
Halfway between the endpoints of a line segment is called the midpoint. A midpoint divides a line segment into 2 equal segments. When you are finding the coordinates of the midpoint of a segment, you are actually finding the average or mean of the x-coordinates and the average or mean of the y-coordinates. The concept of finding the average of the coordinates can be written as a formula. The x values are added together and divided by 2, and the y values are added together and divided by 2.
This right here is the midpoint formula. You've only got 2 points to worry about. You got x and y from each one. So you can take the x value from one and the x value from the other, add them together, divide by 2 to get the average. That gives you the midpoint. So that's all this really is showing. And you'll end up with another point, another ordered pair here that represents the exact midpoint. So you'll have an m value for your midpoint of, let's say it's x3, y3 as your 3rd point. But this is just an averaging game. Figure out what the endpoints are. The midpoint's going to be the average. If you know the midpoint and one of the endpoints, then you got to find the other endpoint. That's a little bit harder, but it's using the same formula and taking the information that you're given and plugging it in until you calculate it.
The midpoint formula works for all line segments, vertical, horizontal, or diagonal. Segment RS has endpoints at 3, 5, and 7, negative 9. Find the coordinates of the midpoint M. Let 3, 5 be x1, y1, and 7, negative 9 be x2, y2. Substitute 3 and 7 for x sub 1 and x sub 2.
So here's your x values. This is one endpoint. This is the other endpoint. Add them together, divide by 2. Same thing here for your y values. One endpoint, the other endpoint. You keep the sign. If you notice here, this negative 9 is the y value that goes in there, just the way that it is written in the ordered pair. So 5 minus 9 is actually negative 4. Divide -4 by 2, and you get -2. The other thing that I like to point out, if you're putting these 2 points on just a straight number line, you're going from 7 down to 3. That's a distance of 4. So halfway between should be a distance of 2. So 7 to 5 to 3. So to be the midpoint, the distance between one endpoint and the middle has to be the same as the distance from the other endpoint to the middle. So you can see these things on a number line too, to check your calculations. Same thing here. If you're going from 5 down to -9, well, that's a total of 14 spaces on a number line. I went from 5 down to 0, there's 5, 9 more below 0, -14. And the spot that is 7 in between here is at where you hit -2 on the number line. So count down or count up 7 from -9 or down from 5. Either way, you end up at -2. Same distance apart from the endpoints.
Then substitute 5 and -9 for y sub 1 and y sub 2. The x-coordinate produces 5, and the y-coordinate yields -2. The midpoint is therefore 5, -2.
Questions, anybody? You can see these laid out on a graph. Again, if they're horizontal or vertical, those are easy to figure out. Just count the squares. The ones on the diagonal, though, are a little trickier. That's why we have to use the midpoint formula. Questions? Pretty much the same calculation every time until you get to here, question number 7. This is one we're gonna work on a little bit. I think you guys can figure out the other one. The midpoint calculation is just averaging. Add them together, divide by 2. When you got to find the other endpoint, though, this is again another spot where a drawing can come in handy. So we have a midpoint and we have an endpoint. P is 3, 5. M is -2, 0. We're looking for that third point, which would be the endpoint. It's another situation where a drawing can be helpful. So here's my endpoint P. I'm gonna call this point over here Q. M is my midpoint. That's not maybe real accurate since I don't have a graph here. But this point is 3, 5. The midpoint is -2, 0. So I'm trying to find what this other x value is, x1 and the other y value. So I'm just going to label them like that for the time being. And we can find that other endpoint in a couple of different ways. The first thing I would suggest is to think about this in terms of counting on the number line. How far am I going for the x value to go from 3 to -2? From 3 positive to -2, how many is that? I went down 5, right? So I got to go down another 5 for M to truly be the midpoint. So from -2 down 5 more, my X value should be -7. Now what I'm doing right now is just kind of estimating. I'm conceptualizing what my numbers should be once I do the calculations. The calculations are going to verify. So here I've gone from, for the Y values, I've gone from 5 to 0, also down 5. So this also has to be down 5, so from 0 to -5. So if I've done that, if I've seen that correctly, then my numbers here in the end should be correct. Well, this involves 2 calculations now. First, for X, my midpoint value is -2. X plus my other X value, 3 divided by 2. For the Y, I have 0. That's my midpoint value. I have Y plus 5, and I'm going to divide that by 2. So you can hopefully see how I've taken the midpoint formula and I plugged in what I know, and I'm solving for the other. Now what OsciWare is showing is multiplying by 1/2. That's basically the same thing as I'm doing. This is cutting this in half. To get rid of this parentheses here, I multiply both sides by 2. Now it's just equation solving. Just solve for X. Take away 3, -7 equals X. That's what I got when I estimated. Same thing over here, times 2. Times 2, well, that's 0. 0 equals Y plus 5, take away 5. This is the only kind of the midpoint problem that takes some thought, seriously. Because you got to think about what you have and what you're trying to find. And that's why, for me, it's always easiest to make a drawing. You might not need that. And if you don't, that's great. Just go jump right into the equation. Anybody have questions about that? And we're going to do one of them. I'm going to give you a chance to do one of these here in a minute. Because this is the hard one. The other midpoint, finding the actual midpoint itself is pretty easy. So, do like I did before. We'll pause the video, give you guys a chance to work on this question number 8. You're trying to find the other endpoint. If you got 11, -2, congratulations. And we'll go back to the whiteboard here. Try to demonstrate that. Again, our points are 8, 2. This is the midpoint. And 5, 6, which is P. We have 2 calculations for X and for Y. We're going to have X plus 5 divided by 2. For Y, we're going to have Y plus 6 divided by 2. Got to get rid of those fractions. Multiply both sides by 2. So it cancels here. Gives us 16 equals x plus 5. And on the other one, leaves us with 4 equals y plus 6. So take away 6. See, there's the sign. If you forgot that minus sign right there, that's how you would get 10. Should get -2 equals y. Take away 5 from the x value, you get 11.
I just wrote it out wrong. I put y minus instead of y.
Oh, yeah, there you go. That's another way to mess up the sign.
Yeah.
So if your actual other endpoint would be 11, -2. That one would go over here somewhere, 11, -2. If you put it on a number line, it could look something like that. Or maybe the other direction, I don't know, it doesn't matter. Visually, 3 points, 1 in the middle. And that's pretty much it in a nutshell for the midpoint formula. These two formulas, it's just a matter of plugging the numbers in the right place and doing the calculations. So there's not really much else to say about that. So if you guys got any questions, if not, we can probably sign off for the day, because the next thing after this is the quiz that goes with those two formulas. And we'll pick up the rest in the next lesson on Tuesday.